Welcome student, I am Professor Golab AM, currently working in the Fulton Education Society's College of Engineering Fulton. Today we are going to discuss about one experiment which is wavelength of the laser by using the plane diffraction grating. So this experiment has very certain importance in the field of the physics, because when we discuss about the nature of the light has dual nature. One nature is a particle nature and another nature is the wave nature. So this experiment is on the basis of the wave nature of the light. So our next main concept which we are using in this particular experiment is a diffraction of the light. So what is diffraction of the light? Whenever the light is traveling from the any door like area, or we can say any slit, the sharp area of the slit causes light to bend from its original path. We know that the light is always travels in the straight line direction, but whenever it passes through any obstacle, whenever it passes through any slit, any sharp object, it bends its path, and due to this bending we are getting the multiple wave fronts, and due to these multiple wave fronts we are getting the interference pattern. More precisely we can say here it has the diffraction pattern. So by using this diffraction pattern we can calculate the wavelength of this monochromatic source. So in this experiment we have here the optical bench, here is our laser source, here is our plane diffraction grating, and we are using here only the plain paper as we are using this screen for these experiments. So firstly we have to switch on this laser. By switching on this laser, we have to adjust this laser to that plane diffraction grating, and as we adjust this laser to that plane diffraction grating, we are getting here the diffraction pattern which we are observing on that particular screen. So in this pattern we are saying that this central spot, which we are saying it as the central maxima, beside that we have two more spots which we are calling it as the first order diffraction, and after these two spots we have two more spots which we are calling it as the second order diffraction. Please come, well, help me, please come. Put this. We have to adjust this on the screen. We can adjust this distance. So firstly we have to adjust this distance as we are getting the proper diffraction pattern on the screen. So we have adjusted some distance. With this distance we are getting here central maximum, first order diffraction and second order diffraction. So in this experiment we have to just calculate we have to firstly adjust the distance between the diffraction grating and the screen, and also we have to calculate the distance of these first order diffraction and second order diffraction by using the scale, and by measuring that only the distances we are getting here some observations. So we are here, we have the observation table for this experiment. First is the observation number, second is the order of the diffraction. We have here two orders. First is n is equals to 1 first order and n is equals to 2 second order. After that we have distance between the screen and grating. We have to just calculate the center point distance between these two, and again we have to measure the distance of the diffraction spot from the mean position. We have to calculate by two sides. First is the LHS and another is the RHS. By taking the mean of these distances, we have to put this mean into the formula tan theta is equals to x divided by d. By dividing both these quantities, x means what? We have here d means the grating element, distance between the screen and grating element, and x is nothing but the mean of these two quantities. And by using the formula theta is equals to tan inverse of x divided by d in degrees, we are getting here the angles. We are going to use this theta into the formula d sin theta is equals to n lambda, and by using this formula we are calculating here the lambda, which is nothing but the wavelength of this laser beam. The more importantly, we are using here the laser beam because it is a highly energetic, monochromatic, less diffraction source. We are getting here the point diffraction, so we can calculate easily. If we use the means what polychromatic source in this particular experiment, we are not able to measure that particular what we can say wavelength of this particular light. So here we are using the HENE laser for measuring the wavelength of the light or wavelength of the laser by using this plane diffraction grating. More information about this plane diffraction grating: it has a slits. For 1 inch, it has the 15,000 in slits we are getting here in this for 1 inch. So according to that measurements, we have to calculate the grating element of this, which is denoted by the small d. So this is about all the experiment which we are studying here in the FYB Tech, which is the wavelength of the laser by using plane diffraction grating. Thank you.